So hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about previous year questions of 20 plus years, basically for GATE, electrical engineering, engineering mathematics for the topic ordinary differential equation. So basically for the concept of ordinary differential equation, you can visit the one short video on my YouTube channel MS Maths. Now let's start the topic. So first let's start the question. So first question is it is related to system of differential equation, and it is one of the new question, and what is the solution for this case, we'll see. This is the recent one question 2025, and it is very important question because it is new in the question. Okay, this is the new question. It is related to system of differential equation. What is the system of differential equation? So you have x1 dot of t is equals to 2x2 and x2 dot of t is equals to r of t. Okay, so this is basically the differential equation which is non-homogeneous system of differential equation. It means if you are going to formulate in the system, it will be x1 dot x2 dot. Dot means the derivative here is equals to, so the coefficient of x1 is equals to 0, coefficient of x2 is 2, and the coefficient of x1 and x2 are 0 here, so it will be x1 and x2. Now the homogeneous or the non-homogeneous part in the first differential equation, it is 0, and second one it is 1, and it is r of t. Now what is the solution for this differential equation? For this case here we have r. They have given the r is nothing but here 1 and 0 for t is equals to greater than 0 and for t less than 0. Now we will find t is equals to 1. It means at like x1 of t. Okay, so what is the solution for this? First of all, we will have like the solution is basically nothing but phi of t, and it is nothing but the L inverse. Okay, I will show what is the L and all these things. So L inverse. Okay, this will be the like s I minus a whole inverse. I will show what is all these things. S is any variable is here, then it is nothing but L inverse and the matrix I will find. So this is the solution. So I'm going to proceed. I'm proceeding with the step by step. First of all, what is A? A is nothing but whenever you will have system of differential equation, it is in the form of x dot A into x plus some non-homogeneous function. So what is my A? A is nothing but 0 to 0, 0. Now what is Si minus A, where I is the identity matrix? What is this? It is S2, or basically, yeah, it is S minus of 2, and it is 0, and it is S. Again, if I will find S of I minus of A whole inverse, how can you find the inverse? You are just replacing that principal diagonal. It is nothing but S and S. And what is this? This is nothing but your opposite diagonal. Change the sign of opposite diagonal. And what is the determinant? It is nothing but S square or 0. So it will be, and divide by S square. What is the inverse? Inverse is nothing but the adjoint divided by the determinant. Determinant is 1 upon S square. This is nothing but 1 by S. This is 2 by S square, 0, and this is 1 by S here. Now, what is phi? It is called the state transient matrix. State transient matrix. So the state transient matrix is called phi of x, and it is nothing but L of inverse. Okay, L of inverse is basically the matrix Si minus A inverse. So what is this? This is nothing but L inverse, and the state transient matrix is this. So it will be 1 upon S, 2 upon S square, 0, 1 upon S square. Now I'm going to multiply this L inverse. So here my phi of t is nothing but, now I can write it as u of t. It means that whenever we will have this kind of this kind of form of the like phi of t, we are just going to replace it as u of t, and this is what, 2 t u of t, and this is 0, and this is u of t. It means 1 upon S will be the u, and if it is 1 upon S square, then it will be 2 into t into u of t. Now what is this? X of t is equals to phi of t into x of 0 plus L inverse, and this is the state transient matrix here, that is Si minus A whole inverse B u of s. Then what is this? This is nothing but the solution of this. Now here you are going to find this matrix. This is what? S of I minus A whole inverse. Okay, and this is nothing but b u of s. So what is this? This is the matrix, this is known matrix. What is b? B is the vector, that is 0 1. That is what? This one. Okay, this is b. Okay, I can write here, it is b. So this is nothing but what? 1 upon s, 2 upon s square, 0 1 upon s. So it is 0 and 1, and it is us. Us is nothing but 1 by s. So what it will be, if we will multiply this, then we'll get 2 upon s square. Of course, this will be 0, then 2 upon s square, and this will be 1 upon s, 1 by s. And it will be 2 upon s cube, and it will be 1 upon s square. This matrix will be 1 upon s square. So after that, what we are going to calculate, it will be L square. So if we'll multiply with this L square, this matrix will multiply with L inverse, then we'll get L inverse of this 2 upon s cube, 1 upon s square. It will be t square u of t. Okay, this will be u of t, and t u of t. This will be u. So it is nothing but t square, t, and u of t. So it is nothing but, remember, it is t square by t. Now, what is your state transient matrix here? Then it is nothing but 1, 2t, 0, okay, 0 and 1, and again it will be 1 0 u. What is the solution of non-homogeneous case? It is nothing but t square upon t u of t. And after that, you will put the solution, or basically what is your x1? X1 is nothing but this first row. This one will be your x, because they are asking about only x1 with t is equals to 1. At t is equals to 1, if we'll put x1 of t, it is nothing but t square plus 1 into u of t, and if we'll put t is equals to 1, then it is be t plus 1 plus 1, it will be 2. So the correct answer is 2 for this question. This is the particular solution. You should have an idea about that, this kind of thing. This is the one, like, very recent question they have asked. Okay. Next question. Next one is related to the differential equation. Which one of the following is or are non-linear, basically? Which one is non-linear? So non-linear means that whenever you will have a differential equation in which, if it is dy by dt, okay, where t is independent variable, and where your y is dependent variable. If there are any higher power like y square, y cube are there, it means the higher power of dependent variable are present, then it is a non-linear. If this dependent variable is multiplying with this derivative of the multiply with its derivative, then it will be non-linear. And if any kind of non-linear function like sine of y, e to the power of y is present in that case, then it will be non-linear. If all these three, or anyone from these three will present in that equation, then that will be a non-linear kind of differential equation. So see, it is what? T is multiplied with x. It means here my t is independent and x is dependent. So independent can multiply with the dependent. So it is what? It is nothing but, it is asking about non-linear case. So here, is it non-linear? No, there is no, yeah, it is e to the power of t, but it is a function of t, it is function of independent variable, then this is not non-linear. It means it is a linear. Okay, see, one thing is here, that here we have what? X is multiplied with the x. It means y is multiplied with dy by dt. X is multiplied with its derivative. It means if I have x is I have x is dependent variable, and it is multiplied with its derivative part, then it is non-linear, and of course it is non-linear. Here it is what? Cos of t is non-linear function, but it is a function of t, then of course it is a linear. Then yeah, of course it is a linear differential equation. But again, here it is e to the power of, again the derivative portion will come. Again, one thing is that if the derivative portion is coming in any kind of non-linear function, then it will be a non-linear. So it will be linear, this will be non-linear, linear, and non-linear. So these both are the correct option for this case. Next one. Next, we'll have a differential equation. In this, y be the solution of the differential equation with the initial conditions are given, and what is the y1 here. So this is nothing but m square minus 4m plus 4 is equals to 0. Then here it is m minus 2 whole square is equals to 0. Then my root of the characteristic equation is nothing but 2 and 2. It is a repeated root, then my y is equals to c1 e to the power of 2x. Okay, plus c2 into x e to the power of 2x. Otherwise, we can write c1 plus c2 into x e to the power of 2x. This is the same thing. Now we have y0 is equals to 0. It means if I will put 0, then I will get 0, then c1 plus c2. Again, that one thing is that if I will differentiate this thing, so y dash is nothing but c1 2 e to the power of 2x plus c2. Okay, first doing the differentiation of x, it is e to the power of 2x, and another one is x or 2 e to the power of 2x. Now if I am going to put 0 in this case, I will get 1, then it will be c1. Okay, this will be 0, then it is 2 plus, this is, if I will put x is equals to 0, then it will be 0, then it is nothing but only c2. Okay, now I have c1 plus c2 is equals to 0, then c1 plus c2 is equals to 0. Oh, sorry, 1. Then it is minus, minus, minus. It's going to cancel, and this will be the minus of c1 is equals to minus 1. It means my c1 is equals to 1. If c1 is equals to 1, then what? c2 is equals to minus 1. Okay, 1 plus c2 is equals to 0, then c2 is equals to minus 1. Then the solution is nothing but y is equals to 1 minus of 1, wait, this is m square minus 2m, okay, plus or 4m plus 4. Yes, it is correct. Then it is what? 1, or one thing is that 2 plus c2 is equals to 1, then c2 is equals to 1 minus 2. Yes, it is my c2 is equals to minus 1, then it is minus of x e to the power of 2x. Now what is the value of y1? It means I will put x is equals to 1, then it will be 1 e to the power of 2, then it will get cancelled, and the 0 is the correct answer for this question. Next we have a differential equation in which also they have given two conditions are there. So it means the auxiliary equation, it is what? Y double dash plus 2y dash plus y is equals to 0. And the auxiliary equation is m square plus 2m plus 1 is equals to 0. Then this is what? This is basically m plus 1 whole square is equals to 0. It means my y is equals to y is equals to, yes, c1 plus c2 x e to the power of, oh yeah, it is t. So it will be t, then e to the power of m is equals to minus 1 and minus 1. So minus of t is there. So if I will put y0 is equals to 1. Okay. So it will be 1, then it will be c1 e to the power 0, then of course c1 is equals to 1 here. And again y1 is equals to 3 e to the power minus 1. It means it is basically 3 e to the power minus 1, and my c1 is 1, then 1 plus c2. What is the value of t? T is 1, and it is again minus 1. So it is 3 e to the power minus 1, and it will be 1 plus c2 e to the power minus 1. Okay, so it is basically 3 e to the power minus 1 upon e to the power minus 1 is equals to c2. Then it will be 1 plus, or sorry, 1 second. 1 second, is there any mistake? c1 plus c2 e to the power of minus t. Then 1 is equals to this. c1 is equals to 1. Yes, 3 e to the power of minus 1 is equals to 1 plus c2 e to the power of minus 1. Of course, this will multiply here also. Then one thing is that in this question, okay, so here it will be 2 e to the power minus 1 is equals to c2 e to the power minus 1, then 2 is equals to c2. So my c2 is equals to 2. So y is equals to what? 1 plus 2 t e to the power of minus t. And what is 2? Then it will be to 1 plus 4 e to the power of minus of t, then it will be 5 e to the power of minus t. Then the solution, oh yeah, 5 e to the power of minus 2 basically. I'm going to put t is equals to 2. So the answer is the correct answer. Okay, next one. A solution of ordinary differential equation d2y by dt square plus 5dy by dt plus 6dy, and these are the conditions here, and what is the value of this? Okay, just finding this. So the auxiliary equation is m square plus 5m plus 6 is equals to 0. Then it is m plus 3m plus 2 is equals to 0, of course. Then after that it is m is equals to minus 3 and m is equals to minus 2. Then the solution is nothing but c1 e to the power minus 3 of t plus c2 e to the power minus 2 of t. Then y of 0 is equals to 2. Here it means I'm going to put 0, it will be 2 and c1 plus c2, and again if I'm going to put 1, it will be minus 1 minus e3e upon e cube is equals to what? c1 e to the power minus 3 plus c2 e to the power minus 2. Okay, if I'm going to solve this thing, these two equations, I can solve that c1 plus c2 is equals to 2 and c1 e to the power minus 3 plus c2 e to the power of minus 3 is equals to minus 1 e to the power of 3 upon e cube. And how can I do this? I will just multiply e to the power of minus 3 here. Okay, to the power of minus 3, then minus minus plus. This will get cancelled. Then this is what? This is c2 e to the power of minus 3 minus e to the power of minus 2, then minus 2 e to the power of minus 3, and it will be minus 1 minus e upon e to the power of 3. So this will be the c2. If I will write here, this will be the c2, and I can find c1 from this. After that, you can put in this equation and you can find the derivative, and you can put 0 in that case. If it will be 0, then the constant, the summation of these both will be the solution. So it will be minus of 3. This will be the correct answer. You can do the calculation. Next, a differential equation is d of I by dt is equals to 0.21. Okay, then what is the value for this? Okay, this is the condition. Then what is the value of this? Okay, yeah, it is di is equals to 0.21 of dt. Then it is I is equals to 0.21 t plus c. Now it is 10 and the value of t is 4, that is 0.21 into 4 plus c. Then this is nothing but 10 is equals to, it is 0.84 plus c. So 10 minus 0.84. So the c is equals to what? C is nothing but it will be 0.84, then it will be 26. Okay, this will be the c. So my I is equals to 0.21 t plus 0.26, and I is equals to 0.21 into minus 5 plus 0.26. If I will multiply this, then I will get 1.65 will be the correct answer. Okay, it will be 0. Or basically, yeah, just let me check it. 5, 10, then 1 point plus 0.26. It will be minus, I think. Okay, whatever with this calculation, just don't see this. This is the process. Just see the process only. Okay, next. Yes. So the next question is related to the differential equation x square d2y by this. This is the differential equation in which the the variable coefficients are there. Whenever you will have this type of differential equation, just replace this with m minus 1 and replace this with m minus 1. Okay, this is m and this is m minus 1. So this will be the m square minus m plus m minus 1 is equals to 0 here. Obviously, what are you doing? This is the Cauchy-Euler differential equation. It is means your z is equals to log of x. It means you are assuming your x is e to the power of z here. Then it is nothing but m square minus 1 is equals to 0. Then m is equals to plus minus 1. So it is what? Y is equals to c1 e to the power of minus z. It is not x, it is in the form of z. It means the variable coefficient differential equation have converted into the linear kind of differential equation. Okay, so this one is c2 e to the power of z. Now you have what is the one of the solution? Okay, see, y is equals to c1. If I'm going to change this z with log of x, then this will be the 1 upon x plus c2 will be the x. So what is the solution for this differential equation? See, whenever you will have differential equation or linear differential equation, then the sum of solution, it means this one is indivisible solution, this one is the indivisible solution. These both are linearly independent. So x is the solution for this case and 1 upon x is also the solution. So here 1 upon x is the solution. These all are not the solution for this case. Okay. If it is, if there will be x, then it will also be the solution for this case. Next is the question in which we have in which we have d2 x by dt square is equals to minus 9x. We can write it as like m square plus 9 is equals to 0. Then it is what? It is nothing but m square is equals to minus of 9, then m is equals to plus minus 3 iota. It is nothing but 0 plus minus 3 iota, then this is alpha plus minus beta iota. It is what? C1 cos of beta x plus C2 sine of beta x with the multiply of e to the power of alpha x. Now you will have what? It is nothing but 0. So it is y is equals to C1 cos of beta, it means 3 of t plus C2 sine of beta, or it means 3t. So this can't be the option, this can't be the option. Now from this and this will be the solution. But see, can it be the solution? Because it is what? 2 by 3. From where it is going, like from where it is like coming extra term here. So it can't be the solution. Just seeing this, we can say this is the solution. Okay, this is the trick. Next one. With the initial condition, this is the initial condition, and we have this kind of differential equation. This is nothing but dx over dt, and it is 1 upon x by t, and it is 1. Okay, so minus of x will be there. Sorry. Oh no, minus. There is no minus. Yeah. So the integrating factor is what? The integrating factor is equals to e to the power the integration 1 upon t dt. It is nothing but t. Log of t will be there, and log and e will be the same. Okay, so this is the integrating factor. Now the solution x into integrating factor, and the integration of right hand side, okay, dt plus c, okay, plus c. Then x of t is nothing but t square by 2 plus c. What is the case? It is nothing but whenever you are going to putting t is equals to 1, then it will be 0.5 is equals to 1 by 2 plus c. Then c is equals to 0 here. So it is nothing but x of t is equals to t square by 2. So x of t, x into t square by 2. This one is the correct answer. And the thing is that it is what? If I can write it as t by 2, then it is also the correct answer. So then like this is the question in which we are going to discuss k, like with the k is the constant possible solution for the first order differential equation. So whenever you will have this kind of differential equation, dy by dx e to the power of minus 3x will be there. Then just see, it is a variable separation, e to the power of minus 3x dx will be there. And if you are going to integrate this, it will be y e to the power of minus 3x upon minus 3, okay, plus c will be there, or plus k will be there. Then the solution for this differential equation is, of course, minus 1 by 3 to the power of minus 3. So the first will be the solution of this differential equation. Another one, this is nothing but the differential equation in which the auxiliary equation is m square plus 6m plus 8 is equals to 0. And you can see what is the root of this differential equation. Of course, this can't be the root. It is 6, 4 and 6. This can't be the solution. This can't be the solution. Then what is the solution for this case? Then from A and B, this may be the solution. See, if it is a minus 6 and minus 4, then the solution is, it is a x, then x is equals to c1 e to the power of minus 6x, okay, minus 6t, and c2 e to the power of minus 4 of t. Okay, here we have x of 0 is equals to 1. It means I'm going to putting t is equals to 0. So it will be what? 1 is equals to c1 minus c2. Just see, whenever you will have this kind of thing, just think over it. The sum of the coefficient, this one, the sum of the coefficient will be 1. Here it is what? 2 minus 1, it is 1. But here it is what? Minus 1 and minus 2. Is it? It is minus 3. The sum should be 1. This is the one of the trick. The sum of the coefficient, the sum of the arbitrary constant must be equals to 1. Okay, so this will be the answer. This is not the case. Next one. So this is the solution of the first order differential equation. This is the simple dy by dt is nothing but minus of 3x. Then we can write it as, dx by dt. Sorry, it is dx by dt, then dx over x minus of 3 dt. Then the integration is nothing but log of x minus the constant. I can write it as like this. It is minus 3t. Then it will be log of x by c. It is minus of 3t. Then x is equals to c e to the power minus of 3t. Now we have this differential equation. Then we can just write x is equals to x0 e to the power of minus 3t. Then it is x0 e to the power of minus 3t. This one is the correct answer. So this is all about the question. So thanks for watching my video. Keep watching MS Maths. In the next video we'll discuss the question. These are all the PYQ of GATE. Thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.